get to introduce me, which is always fun, because I can say anything I want, and it's got to be right. But actually, I don't have to introduce me, because if we can roll the video, I've made a slide to introduce me, because digital technology means all of us are typographers and graphic designers, whether we want to be or not. Whenever we create a slide, we send an email, we write a web page, we design a screen for our mobile application, we have to choose a font or accept the default. And the fonts that we choose, they send a message about who we think we are and the kind of conversation we want to have. So I got this title slide here, and this just says, from hot metal to HTML, the story of typography, my name, my email. Now, if I had this title slide, this sends a sort of slightly different message, doesn't it? You're like, oh, Times, classy, newspaper font, oh, very highbrow. Or this one, the people down the front are going, oh, I like it, it's minimalist. The people at the back are going, what does that say? I can't read it. Or this one. You're like, oh, cool, there's going to be knights in shining armor and the castle of King Henry. Or this one, martial, military, you'd see it stamped on an ammunition crate. You're like, oh, I wonder what this guy is going to be selling. Or the Nordic death metal font. You have no idea what it says, but you know it's going to be rock. Or the world's most misunderstood typeface, about which we'll be here. You're thinking, is this guy really opening his title slide with Comic Sans? But after going through all of those, I come back to this, and this one kind of doesn't say anything. Like, it has none of those connotations, none of those implications. And that's because this font was designed to say nothing. It was designed by this guy. This is Adrian Frutiger. He's one of the greatest type designers of the last century. And he was commissioned to design a new font for the signs at Charles de Gaulle Airport in Paris in the 1960s. And his perspective was, if you are looking for information at the airport, all you want is the information. You don't want to remember anything else. He had this lovely quote about design and function. He said, if you remember the shape of a spoon with which you just ate some soup, then the spoon had a poor shape. Now, this talk is the story of typography. And we are going to go way back. We are going to start here, very, very early days, 5,000 years ago. This is the river valley in ancient Mesopotamia between the Tigris and the Euphrates rivers. Now, this is kind of a turning point for humankind, right? Because by this point, we've had spoken language for probably tens of thousands of years. Nobody is exactly sure. But this is the first point in history where human beings actually started settling down, building settlements, building villages and cities. We started farming instead of hunting and foraging. And we had the first world problem that anyone ever had, because for the first time ever, there were human beings who had too much food. The crops were growing really well, cattle were healthy, they had more food than they knew what to do with. And so the priests looked at this and went, I've got an idea, lads. How about we get them to give us all the food, and we'll keep it safe in the temples, and then in the winter, if the food runs out, we can give out the food that's in the temple, and we can look after everybody, and that way we'll never run out of food, and we'll be really immensely rich and powerful. And they quickly realized that if they were going to do this, they were going to need to keep track of who had given them how many bushels of corn, who had given them how many cows. And so they started using marks in clay tablets to keep track. Now, by this point, we have invented all sorts of concepts that are quite hard to draw in a clay tablet. And so we're going to start things off now. We're going to do a little bit of audience interaction, a little bit of a quiz, really easy one. What I'm going to do, I'm going to show you a picture. I'm going to count 3, 2, 1, and then we're all going to shout out the name of the country, okay? You with me? We'll start off with a nice, easy one. 3, 2, 1. That is Australia. Let's do another one. 3, 2, 1. Sweden. That is Sweden. Let's try another one. 3, 2, 1. Germany. France. Let's do another one. 3, 2, 1. Lithuania. Another one. 3, 2, 1. Portugal. 3, 2, 1. Did I hear Tanzania? That is the flag of Tanzania. Let's make things a little more interesting. 3, 2, 1. I did not hear anything approximating a consensus there. Can anyone read this? Canada. This says Canada in Japanese. But once you've heard the sounds, you're like, Canada, okay, I know what country that is. How about this one? 3, 2, 1. Thailand. One more. 3, 2, 1. Romania. Now, we've demonstrated here 3 different kinds of writing systems. The first one is pictograms, or pictographic writing. If you want to communicate an idea in print or on a piece of paper or a clay tablet, you draw a picture of the thing you are talking about. Even if you did not speak, read, or write any human languages, if your spaceship arrived from Alpha Centauri and we gave you that and said land in the middle, you would know where to go. If we said find this thing, you'd probably end up in Paris. You might end up in Vegas, where they have a little one just to show off, you know. Now, pictographic writing, the origins of a lot of the use of pictography in modern communication come from the Tokyo Olympic Games in 1964. Because Tokyo 64 was the first time that Japan had hosted a really big international event. And they had to deal with the fact that the athletes, the spectators, the journalists, all of these people visiting Japan could not read, write, or speak Japanese. They couldn't even decipher the alphabet that was used to write Japanese. And so they created a set of pictographic symbols and signage. If you were hungry, you looked for a knife and fork. If you were thirsty, you'd look for a teacup. If you wanted to find the bathroom, the shower blocks in the Olympic Village, you looked for the picture of the person taking a shower. Now, in ancient Mesopotamia, the priests and the farmers started out by drawing cows in clay tablets and probably writing them on parchment and vellum and papyrus, but those have not survived. But what we do have is the clay tablets. That's how we know how this evolved. But as this system caught on, they kind of realized they didn't need to draw the entire cow. They could sort of get away with a sort of cow shape. And at some point, this thing got rotated 90 degrees. And people started seeing this picture who had never realized that this used to be a picture of a cow. They just associated this symbol with cow, and some of them weren't entirely sure why. Now, this gets us onto the idea of ideographic writing. This symbol, we all know what this means. It's ubiquitous because comic books are a sort of cultural staple of every civilization on Earth. But this is not a picture of anything. Nobody has ever had bubbles come out of their head when they're saying something. We've just all learned to interpret this symbol. Now, something that I find fascinating is that as technology and culture evolves, we have things that have gone from being pictograms to being ideograms right before our eyes. When Microsoft launched Windows and Office in the 1990s, that was a picture of the thing you saved your work onto. So you'd get your blue disk out of your pocket or out of your desk, and then you'd click the button that looked like the thing you were holding. The floppy disk is basically dead, and it's never coming back. But this thing has survived. And there is now a generation of computer users who know that that is the save button, but they don't know why. And then they find, you get kids will find a floppy disk in mum's drawer and come downstairs going, Mummy, Mummy, why did you print the save button? Now, the thing about ideograms is you can't figure them out by looking at the world around you. Somebody needs to tell you what they mean. I am in a bunch of different Slack workspaces, and there is a convention that is used in Slack and WhatsApp and a whole bunch of messaging things where you'll post a comment, hey, it looks like the media CDN's gone down, there's no images, anyone know what's up with it? And someone will reply with this. Now, this can mean one of two things, depending which Slack workspace I'm in that day. It can mean, ooh, I am watching this because I also want to know the answer, or it can mean, I am looking into this for you and will get back to you quickly. Now, there is no convention. Slack themselves have tried quite hard to say, oh, this means let others know you're looking into this. But have you seen this before? Like people who use Slack a lot, did you know that this is part of the Slack standard? Lots of people don't. Lots of people just use that. And eyes, you reply to a tweet or a WhatsApp or a thread message or something with eyes, it can mean dozens of things. It can mean, I'm watching this is gonna be good. It can mean I am rolling my eyes because I cannot believe that you've been thrown out of another karaoke bar. It has all of these meanings, but they are cultural. They have to be a shared understanding between the people who are communicating. Now, one of the most famous ideograms comes from Tokyo 1964, which was this symbol for bathrooms, because obviously they didn't want to draw a recognizable picture of what happens in a bathroom, so they came up with this. And this has become, it's hard to believe this wasn't used before the 1960s. Now it is completely international, and you'll see the sign everywhere. And the flags on the right here, Lithuania, most of us know what that is because we're here right now. We've seen that flag. Tanzania, I'm guessing most people here didn't know that's the flag of Tanzania because you've never had to learn that. And the Olympic flag, yeah, we recognize that one, but if you hadn't been taught about it, you'd have no idea. Back in ancient Mesopotamia, actually we're starting to spread now because what's happening is people are exporting grain. The Mediterranean has trade routes, sailing ships, trade caravans, camel trains. People are traveling around the ancient world. And the cow has lost its horns and has done another 90-degree turn and has ended up as this symbol. And it doesn't mean cow anymore because the Hebrew word for cow is aleph. And so this symbol stood for ah, the sound ah. You see this written down? Ah, I know what that one means. Now, there is another symbol we get from ancient Hebrew. The Hebrew word for a house is beth. So we had a little picture of a house. Bethlehem in the Bible, it means the house of bread. And this got simplified, and it lost its door, and it got a bit rounded, and it got rotated 90 degrees. And we ended up with this. This made it from Mesopotamia across the Mediterranean Ocean to Greece, and the Greeks went alpha, beta. That sounds Greek. And so the modern alphabet was born. Now this is phonograms. The symbols stand for sounds, and this is incredibly powerful because once you have a phonographic alphabet, anything that you can say, in theory, you can write it down, and then anyone else who understands that alphabet can read it out loud or in their head, and they can get the original meaning back. So we're in a roll. Like human beings are like, yeah, let's invent a whole bunch of stuff. And we are going to invent a whole bunch more things to get to the point where we are today. Now, something that I find absolutely fascinating is paper and books were both invented about the 1st century AD. But we didn't have a paper book for another 1,000 years because paper was invented in China, 1st century, and it was used to make scrolls because in ancient China, they did not use what's called a codex, which is pages bound with covers. We had codexes in Europe, but they weren't made of paper. They were made of vellum, which is very, very fine leather. So it took about 1,000 years before these two cultures met in the middle, and someone went, oh, paper books, that's a good idea. Now, around the same time as paper coming this way met books coming that way, we saw the first kind of adoption of anything we'd consider industrial printing. This guy, Bi Sheng, in the Song dynasty, around the year 1040 AD. Bi Sheng invented the first proper printing press system. Now, most people have not heard of Bi Sheng because the history of printing in China doesn't get a whole lot of coverage outside of China, but there is a crater on the moon named after this guy. So one day people are going to be looking at moon maps and like, oh, I wonder who that was, and they'll look it up in Wikipedia and find out all about him. And he built an early printing system that used ceramic blocks, and it used inks made out of wax and ash. Now, I think part of the reason why his name is not more widely known, Chinese is a difficult language and alphabet. Chinese uses, we're not going to go into it in detail, Chinese has something like 7,000, they're not really letters, they're not really words, 7,000 different symbols. And so to print something, you need to have all of these symbols in your ceramic library and be able to arrange them just right. Now, back in Europe, these books are taken off in a big way. If you want a book, say your friend has a Bible and you think, oh, that's nice, I'd quite like one of those. What you do is you borrow your friend's Bible and you go to find a monk. And you say, hello, could you copy this Bible for me? And the monk goes, yeah, no problem, come back in about 18 months. And they would sit and they would copy the entire Bible page by page by hand, medieval illuminated manuscripts. The thing which was going to change all of this, if you read Western accounts of the development of printing, They will tell you that the printing press was invented in Mainz, Germany by a guy called Johannes Gutenberg, who is the inventor of movable type. Now, Gutenberg was really influential, what he did with it. He didn't just invent this thing overnight. It's like the way Steve Jobs did not invent the iPhone. What he did was he led a project that took a bunch of different technology and ideas that already existed and synthesized them into something which was going to prove revolutionary. And to understand why, what is type? What is type and why was making it movable such a big idea? Now, the word type is massively overloaded. It means about 100 different things. If the type of the type equals type, then you type your program here. And if you press the keys really hard, that's called strongly typed programming. And if you do this, that's weak typing. And all of these things, you talk about, what type of car are you getting? Oh, yeah, she was all right, but she's not really my type. All of these words come from the same root, which was the Greek word tuptein, which meant to strike something, to hit something. And the way that we got them is thanks to these. This is a piece of type. It is a metal block that has had a letter of the alphabet carved into it by hand. Now, this is the master type piece, and this is made of hard metal. This will be hardened steel or iron. Then you take this, and what you do is you hammer it into a piece of slightly softer metal. This is a stereotype. And the word stereotype has come to mean something which is predictable, something which is always the same, because what you'd then do with your stereotype is you'd pour a bit of molten lead in it, let it set, pour some more molten lead, make it set, pour more, let it set, and end up with this, end up with a rack of pieces of type which were all identical. Then you'd take a bunch of these, you would put them in a frame, clamp the frame shut, roll ink over the top of it, stamp it down on a piece of paper, and you have printed one page of your Bible, which is a hell of a lot quicker than getting a monk to do it by hand. Now, this was revolutionary, but it took Gutenberg. He printed a thing called the Gutenberg Bible. This is an excerpt from it, one of the most valuable, rarest books in history, the first kind of mainstream publishing book that we ever saw, certainly in Europe. It took him 5 years to print fewer than 200 Bibles. Now, we're going to fast forward 5 centuries from the 1450s to the 1950s. By about 1952, in the United States of America alone, 50 million printed newspapers were being created, written, edited, printed, distributed, read, and discarded pretty much every single day. And the thing that I find amazing about that is that there was no kind of revolution. There was no quantum leap. All they did was they took the same idea as Gutenberg of using molten lead to make plates to do printing and automated it like nothing you have ever seen. And they did it using what I think is one of the coolest machines ever invented. It was invented by a guy called Ottmar Mergenthaler just before 1900, about 1898, and it's called a Linotype machine. Now, I think there's about 5 of these left in Europe, and right now none of them work because they broke down during the pandemic, and there is one man in Switzerland who knows how to fix them, and he's a bit busy. But the way the Linotype machine works, the thing that makes it work is this thing. This is a Linotype matrix. It's a little brass slug, and if you look at it very closely, it's got the character stereotypes on the front of it. But then across the top, you see this thing looks a little bit like the key to your front door? That is a 7-bit binary encoding that identifies each character implemented in hardware. Now, there is this wonderful visualization that Sylvia Itzigel created for the Museum of Industry in Hamburg. This is how the Linotype machine works. So we want to do some linotyping. So what we're going to do is we're going to sit down at our Linotype machine. It has a keyboard. It doesn't look like any keyboard you've ever seen. And this is actually a German layout. Every time we press a key, one of those matrices is going to drop down from this thing here. This is called the magazine. That's your font. If you want to change the font, you need to get a friend to help you carry it. This is not a drop-down list. That thing weighs about 80 kilos. Those matrices line up here in something called the mouthpiece. Now, hanging off the side of your machine is a crucible of molten lead, because they knew how to build badass machines. And when you push a button, this thing is going to pump molten lead into that little slug that you just created and spit out a Linotype slug. One of these. Come and have a look at this at the end. It's a real thing. Then that thing goes off, gets covered in ink, you stack up a whole bunch of those, and that's what prints your newspaper. But then the matrices get lifted up to the top of the machine and threaded onto this thing. And this is the distributor bar. And it has teeth that match the pattern on each letter, so they all drop down back into the correct place in the matrix. The fastest Linotype is, so there's a documentary about this that I dug up when I was researching the talk. Linotype operators, a lot of them were people who were deaf, because it was something you didn't need to be able to listen to anything, and these made a hell of a noise. And you imagine 100 of these things in a warehouse cranking out the New York Times every day. The world's fastest Linotype operator can produce movable metal type at about 72 words per minute. It's faster than most of us can type. You put those things together, and then you use that to take, so this is the front page of the last newspaper in England that was ever printed with Linotype. This is the original Linotype layouts. This is the printing relief they made from it, and then they take this thing, and they use that to create a drum of molten printer's lead, and that's the thing that you then see in the movies going round, 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 as it prints all the pages. Now, the Linotype machine is amazing. I mean, it is an unbelievably cool piece of technology. By the 1960s, there were about 100,000 of these things in use all over the world. Today, there are fewer than 1,000. And like I said, all the ones that I've found in Europe are currently not working. There's one in Berlin that was working in 2017, but it's broken down now. Now, the Linotype company still exists. Nobody cares about their machines. We don't do mechanical printing anymore. They don't make the machines, they don't make the parts, nobody's in the market for vats full of molten lead. But they owned something else, which was going to prove essential in the age of digital typography, because the Linotype Corporation still exists today, and they sell fonts. Now, fonts are a big deal. Let's talk about what a font is. Now, let's say we're gonna design a font. So we're gonna start off with a line, and we're like, all right, well, what do we want our line to look like? Are we gonna go for a geometric rectangular line? Let's round the corners. Let's make it a little bit soft. Maybe we want to make it a little bit softer still. We want it to look like a flourish, like a brush stroke. Or maybe we're gonna go back for something more akin to like a sort of an Arial Helvetica, or a very sort of stark geometric typeface. How tall are our letters gonna be? Are we going to have a sort of compact, stubby font? Are we going to have a tall, spindly font? How thick are the strokes on our lines going to be? Big, short, fat, wide? Are they going to be the same width? What about the corners? We could put little crinkly edges on it. We could put little rounded edges on it. We could combine them, and we could have little crinkly serifs with rounded corners inside them. Let's take the letter Y. Now, we could do it with straight lines, or we could tuck the tail in a little bit. Instead of a triangle, we could make the bowl into more of a sort of curved shape here. Let's take the letter O. What does the O look like? Is it a circle? Is it a rectangle? Is it a rounded rectangle? Maybe we could make it something more like an oval. Maybe the oval is vertical. Maybe the inside and the outside don't need to be the same shape. Maybe we could put a little slant on it. I like that. That's looking good. Once we've got the O, we get a whole bunch of other letters based on it. We get the P, we get the E, this bar across the middle. How high? How low? Is it horizontal? Are we going to put it at an angle? Maybe we take all the sharp edges off and make this thing look like it's been drawn by hand with a marker pen or a crayon. Designing a font means making every one of these decisions times every letter of the alphabet, uppercase, lowercase, all the punctuation. And if you're being international, you're also doing it for Cyrillic and Hebrew and Korean and Arabic. It is a massive amount of work to design the typefaces that we use in modern operating systems. Now, they weren't always designed digitally. This is one of the world's most iconic fonts. Does anyone recognize this? Anyone? There's a giveaway with this font in that the O and the Q are perfect circles. It's called Johnston, and it was designed for the London Underground network, and it's still used on all the signage on the London Tube and the London Railway network. And this is an original kind of hand-drawn set of proofs for this by Edward Johnston, the typeface designer who created it. So Johnston would create this and give it to one of the team, and they would then make the type masters for this in metal. Now, steel, worked by hand, has an almost infinite resolution. If you're patient enough and you have a good enough lens, you can get it down to a couple of molecules of precision. So the degree of precision and detail and elegance that you could get in industrial hot metal movable type was astonishing. Now, while the world is happily going, yay, 50 million newspapers a day, a bunch of hobbyists are going, well, this is interesting. Look, we've got computers. Now, This is about 20 years after the first computer that could cope with text. This is the PDP-1, and the PDP-1 had an IBM Selectric typewriter that they had hacked, so it had a keyboard and it could do text output and stuff. And there is a wonderful side note in the history of digital typography, which is this. This is Radio Electronics magazine from September 1973. The subtitle there, "For Men with Ideas in Electronics," because I don't know, the 1970s was a weird time. But this had an article by a guy called Don Lancaster about how to build a TV typewriter. Now, this is a thing where you push keys and letters appear on your TV screen. And then you switch it off and they're gone. You can't edit it. It doesn't have any memory. You can't print. You can't email. You can't do anything except put letters on a TV screen. It is a completely useless project, but it also laid the foundation for a lot of the innovation that was going to drive the next revolution in typography. Now, ASCII is established by this point. We've had ASCII in place since long before we had any kind of high-definition displays. We know the numeric codes of all of the letters of certainly the American English alphabet. So what actually happens when you push A on the keyboard of your 8-bit mini computer? Your keyboard sends 65. That's the ASCII code. And that goes into something called a ROM character generator. This is basically a big dictionary implemented in ROM that maps 65 onto this number here. Now, that number doesn't mean anything. The actual number is only important because in binary, it looks like this. And if we take the binary representation and we stack it so that it's a 5x5 grid, a bit map, we get this shape. And so this is how the letters of the alphabet actually appear on your screen as you go through pressing the keys. Now, around the same time that all this stuff is going on, there is digital typography of a sort. Donald Knuth, who wrote The Art of Computer Programming, you know that thing that nerds do where you're supposed to be getting some work done, but then you find like ooh, I wonder if I can hotwire my Wi-Fi adapter so I can bounce it, or like, ooh, I wonder if I can bootstrap the firmware on my Raspberry Pi. And so you go down a little rabbit hole before you get back to what you're supposed to be doing. Donald Knuth stopped writing his book for 10 years to create an entire industrial digital typesetting system because he wanted to print his book the way he wanted it to be printed. And he invented something called TeX, T-E-X. Have any of you used TeX? Have any of you used TeX for, that's interesting, wakey, wakey, come on computer, it's all right, we're here, we're right here, that's fine. Have any of you used TeX for anything other than that one undergraduate paper that you had to use TeX? Because your professors said, all of your work will be in TeX in the future. And you're like, it won't, it'll be in Word, because I've been outside and I've seen what industry is doing. Now, TeX produced wonderful output, but you didn't get to see it, because what you got to see was TeX source code, and TeX source code looks like that. And you could write that in Vim or VI on your Unix mini computer, and then you'd send that to a typesetter, and it would produce a nice proof, and you'd get that sent back. Now, there are two things about the history of digital typography that really stand out every time I sort of think through how we got to where we are today. One of them is the number of things which were absolutely groundbreaking, revolutionary when they first happened, that now we're like, yeah, we just take it for granted, of course it works. And the other one is how many of those things were created by the same company.
Today we celebrate the first glorious anniversary of the information purification directives. We have created, for the first time in all history, a garden of pure ideology, where each worker may bloom, secure from the pests of a contradictory force. Unification of thoughts is more powerful a weapon than any fleet or army on earth. We are one people, with one will, one resolve, one cause. Our enemies shall talk themselves to death, and we will bury them with their own confusion. We shall prevail.
On January 24th, Apple Computer will introduce Macintosh. And you'll see why 1984 won't be like 1984.
That commercial was directed by Ridley Scott and broadcast in the Super Bowl halftime. the most expensive advertising slot that is available anywhere in the world on any television station. Macintosh, 1984, actually there were three things that made it revolutionary. The Macintosh system itself shipped with a bunch of fonts, and Apple did not want to go to Linotype and license anything from them. So they hired somebody, this lady, Susan Kerr, to design a set of fonts for them. And some of those fonts were obviously tributes. Like they had one called New York, which was New York Times, which was a Times New Roman face. And they had one called Geneva, which was obviously supposed to be like a Helvetica Swiss-style face. And some of them were completely original. Susan created a font called Chicago, which was iconic, and that cropped up again 20 years later because it was the default font on the iPod when that first released. Now, the fonts were one part of the puzzle. The second part was a piece of software called PageMaker. And yes, I did actually boot Apple System 1 on a VM just to get that screenshot. PageMaker was the first software in history that let you, what you see is what you get. You could put a page in front of you, and you could lay out the type and see how things were going to be arranged and everything. But the third piece of the puzzle, the most powerful computer that Apple launched in 1984, was not the Macintosh. It was the thing next to it, the LaserWriter. The Macintosh had an 8 megahertz processor. The LaserWriter cost about $7,000. It had a 12 megahertz processor. It had 512 kilobytes of RAM. It had a 1 megabyte frame buffer, which doesn't sound like a lot, but this is 1984. You know, megabytes hadn't even been invented yet. And the reason why they needed such a powerful printer is that every one of those fonts came with a screen version, and the screen versions had a problem. Make them bigger, they look like crap. Bitmap fonts look terrible when you scale them up. So as well as the screen version, there was a print version of every one of those fonts. And those print versions were beautiful because they worked on mathematics. Now let's say we want to draw a dot. We want to draw a circle that is 1 inch across. Now, we are going to work in inches because print works in inches, even in countries that have embraced the metric system, i.e. the entire world except North America. But print works in inches. Dots per inch is the ubiquitous term for all kinds of things. So we want to draw a circle. Now, the formula for a circle, we got the 4 inches, that's the coordinates of our center point. We got a 0.5 inch radius. So for each point in that circle, if px minus 4 all squared plus py minus 4 all squared is less than 0.25, then we are inside the circle and we paint it. Otherwise, we don't. The math is simple. Maths. Listening to Guy Royce too much. The maths is simple. There's more than one math here. It's multiple maths happening. Now, there we go. Question is, how many dots? And it turns out the Apple LaserWriter had a resolution of 144 dots per inch. So our 1 inch circle has 20,736 dots in it. Now we need to do, so we got px minus 4, that's 1, squared, 2. Py minus 4, 3, squared is 4, less than, or add those two, that's 5. So we've got 6 floating point operations need to be done for every point in that circle. 120,000, 125,000 calculations to draw a circle. That's why the LaserWriter was the most powerful computer you could get, because it had to be able to crunch all those numbers just to draw a circle. If we wanted to get really fancy and draw a letter O, now we got to figure out, well, everything that's inside the circle, but not inside the ellipse. And now we have twice as many calculations to do. If we want to get really, really, really fancy, maybe we're like, well, let's draw a B. So we got a circle and a block and a this and a that, and then we don't want that bit, and we don't want that bit, we don't want that bit, we don't want that bit. So we calculate the points which are inside these shapes, but outside those ones, and we fill those in. Now, this produced absolutely beautiful type. The quality of the print from the LaserWriter was like nothing anyone had ever seen. The third piece of the puzzle was Adobe PostScript, a page description language, which is what drove the printer. Now, PostScript cost about $100. If you wanted to put it in your device, you had to give Adobe $100 for it. And as the 1980s rolled into the 1990s, it was becoming increasingly clear that this separation of bitmap fonts and vector fonts, screen fonts and printer fonts, these were going to converge on something. The problem was computers were getting fast enough that they could crunch these kind of numbers almost in real time. But let's take our letter B here. Now, on the screen, we don't have 144 dots per inch to play with. We've got maybe 50, if we're lucky, on a VGA display in the 1990s. So how do we draw a letter B? Well, let's fill in all the pixels which are inside the outline, okay? Anything that's 100% inside, yay, B. Yeah, it's not going to work. All right, maybe, what about anything that's more than 50%? Yeah, kind of, it's legible, but we've lost a lot. Maybe we could fudge it, and we could sort of have a 50%, and now we get something a little bit nicer, but now it's all getting a little bit blurry and everything. Now, this is where Apple and Microsoft get together and go, do you want to give Adobe any money? And Microsoft are like, hell no. We're not giving Adobe money for every copy of Windows that we sell. Why don't we invent our own type system? And they did. TrueType. And TrueType basically did the stuff I just showed you with the circles and the rectangles and all this kind of stuff. But it added something else. It added a technology called hinting. And hinting means you design your font, but then you go into your font designer, and you go into every single letter, and you say, look, if you're drawing this letter 8 pixels high, these are the exact pixels that you are going to color in. Hinting is a bugger. It is one of the most labor-intensive things that it is possible to do with a digital computer, but it works really well. You get these beautifully crisp outlines. Now, TrueType didn't quite make it into Windows 3.0, but it made it into Windows 3.1. And if you go into Windows 3.1, as I do daily, obviously, and I go into my control panel and I go to fonts, you see here, this is a scalable TrueType font that can be displayed on screen and printed on your printer, and you could switch TrueType on and off. This was still kind of an experimental technology. They're like, it would be a good idea if your screen looked like your printer, but we're not 100% convinced yet that this thing's going to work. But if you zoom right in, you can see the hinting. You can see the individual pixel-perfect precision that has been used to create these. Now, the next kind of significant chapter in the history of digital typography came about as a result of Microsoft wasn't really sold on the whole Windows thing. I mean, they thought it was a good idea, but they weren't going to bet the company on Windows because maybe people didn't want to drag and right and click and right-click. Maybe people wanted to interact with their computer using an analogy for the house, where if you want your appointments, you click on a calendar. And if you want your recipes, you click on the kitchen. And if you don't know what to do, you ask the dog. And a type designer called Vincent Conair was looking at an early prototype of Microsoft Bob and asked the completely legitimate question, why is the dog talking to me in Times New Roman? That is not an appropriate typeface for a cartoon dog. I'm going to design a new one. I'm going to design a sans serif typeface that looks like a comic book from Microsoft, Comic Sans MS, and he did. And one, Comic Sans never made it into Microsoft Bob because it didn't fit. 2, Microsoft Bob never shipped. Steve Ballmer took it quietly out the back and shot it and said it was a rare example of Microsoft canceling a bad idea before it got too late. But Comic Sans escaped. It was in the Windows 95 Plus pack, if anyone is old enough to remember that. And then it shipped with with Office 97 and became ubiquitous. Now, Comic Sans is a perfectly good typeface. See? Clear, readable, friendly. It's the people using it that are the problem. If you are sending invitations for your kid's dinosaur-themed birthday party, absolutely, Comic Sans is lovely. If you're writing a comic book, Comic Sans is lovely. If you are sending the invoice for somebody's husband's funeral, maybe not. Like, hey, we your husband, but in a jokey way. Yeah. Comic Sans remains a hugely contentious and misunderstood font just because of the number of places that it has been used when it is completely the wrong thing and it sends completely the wrong message. Now, we're into the second half of the 1990s now. The next big thing that happens is that computer monitors stop looking like this and they start looking like this. We've invented flat screens. And it turns out that flat screens have a particularly interesting property when it comes to typography. If you go to Google and you get a screenshot and then you take it into Photoshop and you blow it up, you get these weird little colored fringes. All the letters here, they got kind of like an orangey stripe on one side and they got like a blue stripe on the other side. But If you take the same screenshot, now we're not going to take a screenshot and blow it up in Photoshop. We're going to take a photograph with a macro lens on a high-definition camera, and we are going to zoom in on that, and what you see is actually this. Because every one of those pixels on an LCD screen is actually a little red bit, a little green bit, and a little blue bit, side by side. And what Microsoft figured out in the 90s is that you could exploit that to triple your effective horizontal resolution. If you make your letter B look like this, what you've actually got is the ability to switch on and off a third of a pixel. And when you kind of munge it all together, what you get is this, which is a significantly higher definition. Microsoft called this ClearType. They announced it at Comdex in 1999. There was like a huge song and dance. They filed a patent for it. But what's really interesting is Microsoft didn't invent it. It was invented by Steve Wozniak in 1977 to get high-resolution text on the Apple II. And the reason we know this is that the Microsoft Basic Interpreter Manual from 1982 explicitly calls out the fact that there is this high-resolution thing you can do by hacking the colors if you're programming Microsoft Basic on the Apple II. Now, I have no idea whether Microsoft just forgot that they already knew that this had happened and genuinely rediscovered it, or whether someone went, hey, look at this memo, and then forget we ever saw anything. But yeah, ClearType was invented by Steve Wozniak in the 1970s and then cropped up again 20 years later in Windows 98 and Windows 2000. Now, while we're talking about the Apple II and this sub-pixel font rendering, something that I've always been fascinated with is what's the smallest font you can make? And the smallest one that I found for a long while was this one. This is a guy called Michael Koss. And Michael Koss created this for a terminal emulator on the Apple II. And every letter in this font is drawn on a 5 by 3 pixel matrix, which means they have 15 bits each. So each letter fits inside, the bitmap for a letter fits inside a 16-bit number. And I thought this was the smallest font you could get. And then I gave a version of this talk a couple of weeks ago in Porto, and someone came up to me afterwards, and they said, do you know about subpixel text encoding? I was like, no, what's that? And they sent me this link, and this is fantastic. Now, you see the tiny little colored image there? That image looks like this. But if you zoom in with a magnifying glass on an LCD display, it's actually an alphabet. So this is a 3 by 5 matrix. He's created another one. This one uses 2 pixels side by side, but it never uses the right-hand column of the second pixel. So you can have your pixels right up against one another. And again, if you look at it like this, it looks like gibberish. It doesn't appear to say anything. But if you visually, optically magnify it on an LCD display, it's readable text, and you can see what's been encoded in there. So this is literally encoding a 2 by 5 pixel block is enough to give you high-fidelity character rendering. Now, the 1990s kind of rolls around. There was a period there where fonts were everywhere because when you bought a CorelDRAW, for example, it came on a CD-ROM, and they had all this extra space to fill up. And so they're like, well, we'll give you 2 CDs, and the other one's just full of fonts. Fonts, 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 fonts. Fonts everywhere, all these TrueType fonts. And fonts were amazing, and everyone loved fonts. And just as we were getting used to the idea that we had WYSIWYG and we had TrueType and you could design something on your computer and it would look like that when it got to your customers, someone came along and invented the web. And they invented the web using dial-up modems, if anyone was in Vitaly's talk this morning with the dial-up modem-y noise. Now, dial-up internet sucked ass. It was really, really slow. And if you were creating websites in the 90s, as I was, and I'm sure a couple of other folks in here were, you kind of had this problem because your customers would come to you with this wonderful glossy brochure or product catalog, and they'd be like, yeah, we want our website to look like this, and it would have Helvetica, and it would have these wonderful colors. You'd be like, yeah, no, sorry. The web in the 90s, basically we can give you this. It's about as good as it gets. Now, the web was too slow for you to provide a font to go with your website. And even if you did, even if your customer was going to sit and take the time and wait for it to download, then they'd need to install it with system administrator level access to get anything to render. And then they'd have to close and reopen Internet Explorer or Netscape to get it to render. It just wasn't going to work. But there was a technology built into the first version and all subsequent versions of CSS, which would allow you to say, all right, this web page We want you to render it in Futura semi-bold if you can. If that's available on the target system, use that one. If you can't use that one, use Helvetica. If you don't have Helvetica, use Arial. If you don't even have Arial, just anything sans serif will do. This kind of, progressive degradation of fonts. Now, there are not a whole lot of takeaways in this talk, but I am going to give you a technique here. Now, remember, with great power comes great responsibility. I want you all to swear that you will use this knowledge ethically. Because you're going to need three things. One, you need a coworker you don't like very much. Two, they need to be running Microsoft Windows. And three, you will need a copy of FontForge, the open source font editing and manipulation software. Now, what we are going to do is we are going to go onto defont.com, and we're going to find something cool. We're going to find something, extra groovy. There we go. Abstract groovy. That's kind of nice. And it's 100% free, according to defont.com. I don't entirely believe them, but it works for the purpose of the demo. So we're going to download Abstract Groovy as a TrueType font. Then we're going to open that font up in FontForge. And we are going to go over here. We're going to go into Element Font Info. And we're just going to change the font name. And we're going to change it to Helvetica Neue. Because when Apple launched their Retina displays on the iPad and the iPhone, Helvetica Neue was the really cool typeface that all the thin Swiss people in the berets were using, and everybody wants to be cool. And so we're going to save that font as Abstract Groovy, and we're going to export that as a TTF. And then we're going to send that file to our coworker. And what's going to happen is they're going to get it, and they're going to open it, and they're going to go, oh, that looks really cool. Look at it. Oh, it's so 70s disco. They're not going to notice that it says Helvetica Neue in the small print. Was anyone in Rachel's dark UX patterns? Yeah, this is some dark UX we got going on here. They're going to see the funky font, and they're going to go, yes, I want it. And they're going to install Abstract Groovy, and then they're just going to get on with their life because they're not going to notice anything right away. And then a couple of days later, they're going to go to download an update for WhatsApp. And they're going to go, oh, WhatsApp got really into the whole 70s disco vibe. This is kind of cool. And then they're going to get a receipt from the iTunes store. And they're like, oh, Apple has got all 70s disco funky. They're going to try and log into their business accounting software. Basically, every website that wants to be cool and hipsterish and look like an Apple Retina display and use Helvetica Neue is going to look like this. Now, this could be terrible, or you could just embrace it. The world of fintech is a lot more fun when everything is in a cool 70s groovy disco typeface. Now, I actually discovered this technique by mistake. A client sent me a zip file full of fonts for a project I was doing for them. And it had imagine that there was a version of Helvetica that you bought in a street market in China for $1. It was that. And I installed it, and I didn't notice anything until just a bunch of websites looked really bad. And I could not figure out why. It took me about 3 weeks to work out, because Windows doesn't have Helvetica. So if you install a Helvetica font on Windows, a whole bunch of websites suddenly look different, and you'll never be able to work out why. Now, web typography had a challenge because it was a union of designers and developers. And on the one hand, designers have a history going back centuries of working out how to present information visually. There are books about how to teach the history of design. There is this, they've thought about all these things, layout and information flow and fonts and typography and spacing and all this stuff, and they're good at it. They're really good at it. And then you go, yeah, look at this website, and they're like, all right, and you're like, by the way, we can change the width of the page, and all the blood drains out of their face, and they're like, you can do what? And you're like, oh, yes, not fixed anymore. No. The client can control how big the page is. And on the other hand, we have developers. And developers are like, yeah, resize the page. It's fine. And scroll this and do that. And I designed a website for you. And look, it's brilliant. Look how usable my design is. And of course, CSS was supposed to represent the union of these two worlds, taking those 5 centuries of thinking and innovation from design and presenting it in a form that developers couldn't possibly screw up. We got there in the end. Probably the first 5 years of CSS web design was really, really rocky and rough because support was so patchy. But one of the big steps forward came in 2009 with the invention of the Web Open Font Format, WOF. which for the first time meant you could say this website should look like that. It should be rendered in that font. And this idea, not only did it give us control over the way the text on our websites looked, it gave us a whole new toolbox of ways to prepare and present information. Now, have you ever received an email that just ended with a weird letter J on its own? And you're not quite sure why. It's like, yeah, this candidate CV looks great. I know they said papyrus, yada. I'm sure we can make a exception just this once, J. Now, the reason J crops up, there is a font in Windows in the days before Unicode called Wingdings. And a ding is a printer's dingbat here. The printers in the days of Linotype, they'd have a special box full of like playing card symbols and bullet points and all this kind of stuff. They were called dingbats. And Wingdings was the dingbat font. And if you typed a smiley face in Microsoft Outlook, it would replace it with the smiley face from Wingdings. Now, Wingdings, we didn't have Unicode. We didn't have space for lots of new letters. What it did is it reassigned character codes. So if you typed a letter A in Wingdings, you got victory sign. If you typed a number 2, you got a blank document. If you typed a W, you get a little diamond. Now, in the mid-90s, a computer consultant working in New York noticed that if you type NYC in Wingdings, it gives you a skull and crossbones, a Star of David, and a thumbs up. So he rang the New York Post and said, I have proof of an anti-Semitic conspiracy in Microsoft Windows. And the New York Post went, don't be ridiculous, mate, stop wasting our time. No, of course they didn't. They ran it as a front-page story saying, we've uncovered proof of this conspiracy. It's complete crap. It's a total coincidence. The character allocation was random. But this must have got back to Microsoft somehow, because when they launched Webdings in Windows 98, if you type NYC in Webdings, and yes, the reason for the J is that at the end of the email, you type your smiley face, and it gets replaced with that. The reason I remember this is I used to work for someone called Jay in a company that used Microsoft Outlook. And just once in a while, I'd get an email, and I honestly wouldn't be able to tell if he'd just signed it off as J or he'd meant to put in a smiley face, and I'd have to go and read it on a Windows computer because my iPhone couldn't make sense of it. Now, you could do some fantastic stuff with custom fonts. My first proper job ever was working for Arup, the engineering partnership. And I was help desk. I was 17 years old, and in my defense, I should not have been left unsupervised, because people would come and they'd ask me, hey, can I put the company logo in my spreadsheet? And the official answer was no, because we had no technology to be able to do that. But I had the Arup logo type, which is this thing, and I had this as a CorelDRAW file, and CorelDRAW could export TTF, TrueType fonts. So I went, yeah, I can solve that. And I exported aruplogo.ttf, and I gave it to them and emailed it to them. And word got around, and after a week or two, my boss comes over and goes, what is aruplogo.ttf, and where did it come from? I was like, I made it. And he's like, you're not supposed to do that. The company's global multinational branding is controlled and must be signed off by a director if you're going to distribute versions of it. I think they were just pissed because no one else had thought of it first. But if you can get the shape or the design or the icon that you want as a font, you can do some awesome things with it. There is a website called Font Awesome. And Font Awesome is lovely, because you go on and you say, look, I want playing cards, I want users, I want icons, I want playback buttons, I want little pictures of R2-D2, except it's called Astromech, so they don't get sued by Lucasfilm. And you can download a font file that includes these at a bunch of different weights, and then you can render your website or your mobile app using that font. And you get, not only do you get this wonderful library of UI elements, but because they are fonts, they are vectors, they are infinite precision, the better your screen gets, the better they are going to look. And innovations in screen technology, 10, 12 years ago, if you told me that I was going to read a novel on a computer screen, I'd be like, no, don't be ridiculous. Nobody is ever going to do that. And I remember the first time I saw an Amazon Kindle in a store, and I don't know if any of you had this. I assumed the one on display was fake. It was like a plastic replica, like the TVs in IKEA, because there's no way that that could be a real computer. And then the salesperson pushed a button and it turned the page, and I was like, I'll buy it right now. Yes, I want that in my house, please. Thank you very much. You know, Kindle is amazing, and one of the fantastic things about the e-ink technology that Kindles use is that it only draws power when you are turning the page. Because every pixel on a Kindle e-ink display is actually a tiny little bubble with black and white electrodes that carry an opposing electrical charge. So when you push the button to turn the page, it works out, okay, black, white, white, black, white, black, zaps the pixels, they float to the top if they need to, but once that's done, they stay there, all by themselves, which is how you can get a battery life of like 35 days out of these kinds of devices. Now, Kindle was an absolute game changer for me. You know, I loved it, I read voraciously on it. Then I discovered this thing. This is an Onyx Books. This is an e-ink tablet that runs Android. And I have an actual electric pencil that goes with it. And this thing, it runs the Kindle app, so you can read books on it. Come and take a look at that at the end if you want. You can do crossword puzzles on it. You can sketch on it. But it's a full Android system. So it'll also do anything that's in the Android App Store will run on there. And they have just announced last year that they have started doing color e-ink displays. High fidelity, it's not quite full color, it's like kind of newsprint color. Like we're not talking, you wouldn't want to watch a movie on this thing, but for reading comic books and doing illustrations and stuff, this is just absolutely wonderful. And so e-ink is getting to a point where we're gonna have basically glossy magazines that happen to be digital and only use power when you're turning the page. And at the same time, mobile phone displays, you know, desktop displays, laptop displays, they are getting better and better and better every day, every month, every year that goes by, to the point where it almost doesn't matter. And it is quite astonishing to think, you know, this is the thought that I want to leave you with. We have a story going back 5,000 years about taking a picture of a cow and turning it into an idea, and turning the idea into a sound, and turning the sound into an alphabet, that is going on to this day and still going on, because every year the Unicode Consortium adds a bunch of new things to the emoji character set, and you and a bunch of your friends have an in-joke where you discover that there's like a woolly mammoth in the emoji set now, and you start WhatsApping that to each other, and you're the only ones who know what that means. And we've got this story going back 500 years about print and printing presses and linotype machines and industrial type design and typography. And we've got 50 years or so of digital computer systems. And we're kind of at the convergence of all of those, and I have no idea what's coming. I do not know what's going to happen next. But I read this book. This came out in the 1990s, Neil Stephenson, The Diamond Age. And I read this in paperback, and yeah, I read it many times. This is my copy. You can see the covers falling off. And then I got it on Kindle. And if you're not familiar with this book, it's a book about a book. It's a science fiction book set in the distant future in a world of nanoengineering and matter synthesizers. And the protagonist, Nell, this little girl, she has a book which is like a smart assistant. And I bought The Diamond Age on Kindle, and I was reading it one night while I was outside waiting for my train. And I hit this. And I had this moment of, holy crap. The science fiction came true while I was holding it. Like, that was pretty amazing. Folks, the future is bright. Technology is amazing. We have so much cool stuff. Let's all go out there, build awesome things, have a great time. Thank you very much.